So I decided to put this video together to give a bit of support for those of you who struggle with the trigonometry of the sine function. So the question we're asking here is, what is the sine function? Well, the sine function is defined as the ratio, you can say that, of the side opposite divided by the side hypotenuse in a right angle triangle. That's the first thing to realise is the sine function will only work like this for the right angle triangle. So obviously you've got your sine, cos, and tan functions, and in their basic form, when you've got opposite divided by hypotenuse, this only applies to right angle triangles. That's the first thing. Okay. So the next thing is how to use the sine function to see what it gives you. So if we have a look at this triangle here, I've got the angle A on the left-hand corner of it, and that means that the side opposite is over here because it's the side opposite to A. The hypotenuse is always easy to identify because it's directly opposite the 90-degree angle. That's the hypotenuse. And the side adjacent is on this side. But for sine, we will be using the side adjacent. So our function, the sine of the angle A, would be the side opposite of the hypotenuse. Right now, we know what all those values are. So that means the sine of A is 6 centimeters divided by 10 centimeters. And the centimeters cancel, and that gives me 0.6. Okay? So I think it's important for us all to realise that the sine of the angle gives us a ratio. Okay? 0.6 or 6 over 10. Of course, you could write that as maybe 3 over 5 as well. Okay? So it's a ratio. It's the ratio of the side opposite is to the side hypotenuse, where the ratio here in this case is 6 is to 10, or 3 is to 5. Okay? That's really and truly what the sine function gives us. Now, that's all well and good. It gives us a ratio. How do we use that? So, a long time ago, people figured out that you can run through all of the angles, everything from 0 all the way up to 360 degrees, and from that we can take the ratios and go backwards, okay, in order to get that angle there. So if I wanted to get the angle A, for example, I know that the sine of the angle A is equal to 0.6. So what I do is I take the sine inverse of both sides. Mathematically, that's what I'm doing. Okay. So taking the sine inverse of a sine function basically drops the sine function completely. But of course, if we take the sine inverse of one side, it means I have to take the sine inverse of the other side. Now, of course, the math books will often ignore this step, but that's really what's happening. We're taking the sine inverse of both sides. So the sine inverse function cancels out with the sine function, and that leaves us with the angle A. And that gives us the sine inverse of 0.6. Now, on your calculator, you'll find the sine inverse directly over the sine button, the second function, generally speaking. So if you take the sine inverse of 0.6, then that works out to be 36.86989, or approximately 37 degrees. Okay? So this tells us that the angle A is 37 degrees approximately. Now, it is worth turning the operation around just so to fully understand what's going on. So that means if I take the sine of the angle, I'll use the full number 36.869 degrees approximately, then that works out to be around 0.6. Okay. So again, the sine of the angle gives us the ratio, the angle that gives us the ratio. 6 over 10, 3 is to 5, 6 is to 10, 9 is to 15. Okay. Whereas the sine inverse function gives us back the angle. Okay, 46.9 degrees, or approximately 47 degrees. Okay, so I do think it's also important to realize that the sine function, I'm just going to zoom out a little bit on this, will work for any size triangle. Okay, so this is right angle triangle. If I was to make that triangle really big, much bigger, so long as I kept the same ratio to the sides, to the side opposite and the side hypotenuse, then the angle has to stay the same because it's the same angle in that corner. So I'll make it as big as the screen will allow me. So I've made the triangle as big as I possibly can on the screen anyway. So I've got the side opposite is 15, the side hypotenuse is about 25 squares. So that means that the sine of the angle in the corner, sine of A, is 15 over 25. And that is divided by 1 over 5, gives me 3 over 5, which is the exact same as we had for 0.6. 3 is to 5. 6 is to 10. So that same angle, regardless of how big the triangle is, will always have that same ratio of 0.6